Hello, welcome to Tech Dictated. Today we are looking at nodal analysis, and in this question we are asked to determine the nodal voltages for this circuit. This is our circuit. Okay, so basically nodal analysis utilizes KCL, which states that the sum of currents at a node is equal to 0. So when you add the currents leaving and those entering, so these ones are entering this node and this one is leaving the node, and also let's say we have another one here leaving the node, the sum of these currents should be equal to 0. So if this is I1, I2 and I3, then I1 is equal to I2 plus I3, or I1 minus I2 minus I3 is equal to 0. Okay, so that is what we're going to be applying in this question. So first we identify our nodes. So we have this node, let's call it VA. We have this node VB, and also, well, you can say we have this node as VC, but already we know VC is 20 volts. Okay, so in order for us to find VA, we can have currents. So we can have this as current I1, then this as current I2. Now, this is ground. So when we have a ground, that means this is a higher potential. We have a higher potential here than here, okay? And current flows from high potential to low potential. So this is our current here and this our current here. Then we can have this current probably just going in, okay? And yeah, that's it for current. So once we've identified the flow of current, I have assumed this current to be going in, and then this I have assumed to be going down because we have this as our reference. If we have a ground here, then that means we can use this as our reference, okay? And it will be 0 volts. And therefore, I've said current goes from high voltage, where there's high potential, to a place of low potential, okay? Okay, and so if this is the case, then current will move from this, which has a certain potential, to this low potential. Yeah. So now let's find the Kcl equations for this. We have I1 is equal to, this is leaving and this is leaving, so is equal to I2 plus I3. Let's have this as I3 and this as I2, this as I4 and this as I5. Okay, so in this we have I2 and I5 entering, but I4 is leaving. Therefore, I4 is equal to I2 plus, which other one? I5. Okay, now using voltages and resistors to find I, we have Ohm's law, which states that V is equals to I R, okay? And therefore, I is equals to V over R. So, I1, we already have it. There's no resistor here. So, I1 just remains to be 2 amps, okay? So, I1 is 2A, okay? Now, I2 will be the voltage difference, okay, divide by the resistor. Now, we've said current moves from a high potential to a low potential, and therefore, for us to find this voltage difference, we minus VA minus VB, okay? So VA minus VB over 6 what? 6 over 6, okay? And then we have I3, of which I3 we have it as high potential, low potential, which is 0 volts, okay? So VA minus 0 over 5, which is just VA over 5, okay? Now, I form VB again minus 0 over 3, which is just VB over 3. Now, I5, we have determined that our I5 is going this way. This is assumed direction, okay? You can assume it to go this way, but this will mean you will do VB minus VC. So since I have assumed it to go in to this VB, then it will be VC is smaller. No, VC is larger. So VC minus VB over 10. Okay, if you have any question, please leave in the comments so that I can address it. So once we've determined this, then we can just plug them in here and get started. Okay, so now using this, we have 3. We have I1 is equals to I2 plus I3. This is node 1. Okay, so in node 1, then we'll have, 2 is equal to VA minus VB over 6 plus VA over 5, okay? Just according to this, we're just replacing I1, I2, and I3. Then we simplify this equation by multiplying it by 30. Then this will be 60 is equals to 5 VA minus 5 VB plus 6 VA. Okay, this like terms, so 60 is equal to 11 VA minus 5 VB. Okay, now to the second node, this is node 1, I don't know if it's clear. To the second node, which is node 2, we have I4 is equal to I2 plus I5. Now this becomes VB over 3 is equal to VA minus VB over 6 plus VC minus VC we said is 20, VC VB over 10, okay? This, remember, is 20. So we can take all to one side. We'll have VB over 3 minus VA minus VB minus VC minus VB over 10 is equal to 0. Multiply everything again by 30 because that's a common denominator. Okay, now we'll have 10 VB minus 5 VA minus, no, this will be addition, so plus 5 VB minus 3 VC plus 3 VB is equal to 0. 30 by 0 is always 0. Now, we can simplify this 10 and this. Then this one 3 times to 20, which is VC is 20, and this. So we'll have 18 VB minus 5 VA, 5 VA minus 20 times 3, which is 60, is equal to 0. So 18 VB minus 5 VA should be equal to 60. Okay, now once we have this, we can now select one and do it on the other. Let me use node 1. So we'll have let's find a VB. Okay, let's find a VB. So this will be 60, 5 VB is equal to 11 VA. Take this 60 to this side since we've taken this here, minus 60 over 5. Divide both sides by 5 so that we just find a VB. So VB will be 11 VA minus 60 divided by 5. Okay, now replace this here. Okay, so we have 18 into 11 VA minus 60 divided by 5. Okay, minus 5 VA is equal to 60. Now 18 divided by 5, sorry, we have 3.6 into 11 VA minus 60. Okay, since this 18 is only for this, so we can just divide it. Like terms, this goes to this other side or vice versa. So we have 39.6 minus 5, 34.6 VA is equal to 60 plus 216 to 76. Divide both sides by 34.6. Therefore, VA is equal to 7.9769. Okay, oh, this is voltage, so V. Okay, now since we have VA, we can just find a VB easily, since we've said VB is equal to 7.9769 minus 60 divided by 5. So VB will be times 11 minus 60 divided by 5. VB 5.5491 volts. So this are our nodes. Okay, this node and this node, and we have all the nodes, and that's it for node analysis. Thank you for watching. View more of our tutorials and subscribe to our channel. Thank you.